Hello everyone, welcome to GChem classes. So today we are going to see the chemical kinetics. So you have requested for chemical kinetics, and that I have prepared something like in one or two lectures. It will be, I think, two lectures. So in the first lectures I'll try to discuss everything, all the concepts, and the second lecture I'll discuss all the PYQs. Okay, I'll not leave any PYQs in IIT-JAM. Whatever they have asked, I'll discuss with you. So discussion is very much important. Then only if because the same question they are not going to ask you, right? But the similar concept they may ask you. So for that, just I think if you are not able to understand these things, this lecture, do what, two or three times you watch it, it will be crystal clear for you, right? So try to understand. Okay, wherever you are finding questions like you are not able to grasp it, you just say hi in my WhatsApp and ask me whatever you want. Okay, and similarly, next day's topics also you should tell me. One of the student has replied for thermodynamics. Okay, so surely I'll take the thermodynamics also for my next topic. After the thermodynamics, what topic should be discussed, that also you can tell me, right? And before starting, today is our Republic Day, so happy Republic Day to all of you. Maybe you can enjoy it today, but half an hour lecture, just watch it, okay? It is in evening time, so I think everything you have finished and you are in home. So peacefully you watch my lecture and practice your problems, right? So we'll start chemical kinetics. Okay, so in chemical kinetics, if you want to learn entire chemical kinetics, it will take you 20 to 25 lectures, correct? But keep in mind your upcoming examination and try to put everything in one lecture, right? So it will be it's a better revision for you before your examination, correct? So first we will discuss all the type of order of reaction and their unit, because they are very much asking the unit, or maybe if some questions they have some problems and they are asking for what will be the rate of reaction. Okay, so based on the rate constant unit, you will identify whether it's a first order reaction, zero order reaction, or third order reaction. So that we are going to discuss it, correct? So based on unit you can easily identify. So first we will just discuss the unit, how units will discover the order of reaction, correct? So first, if n barabar 0, okay, n, what is the n? N is the order of reaction, correct? N is order of reaction. So if n barabar 0 means zero order reaction, correct? Then what will be the unit? So unit, we have basic formula, that is mole per liter. This is the concentration upon time, second, into 1/, again mole, okay, per liter, and then here it will be n. This is the basic formula, right? So when you are taking n equal to 0, you just put it here 0. So how much it is coming? If anything above 0, it will be 1, right? So 1 means this unit, how much it is coming? Mole per liter per second. So this is the unit of zeroth order reactions. Suppose if you are getting any unit saying that so and so into 10 to the power 3 mole per liter per second, rate constant value, directly go that it's a zero order reaction, correct? Likewise for first order reaction, how you will frame it? It will be like mole per liter upon second 1/, mole per liter, and now it is first order reaction, so n equal to 1, right? So n equal to 1 means mole per liter only, so mole per liter will get cancelled out of. So now it will be per second. So if per second is there, per hour is there, it will be first order reaction, correct? Now you are going to be for second order reaction. After second, we will directly go to the nth order reaction. Okay, so in that nth order reaction, you can put whether first order, second order, third order, 10th order, 20th order, whatever order you are going to put, you will get the unit, right? So first we'll see for second order reaction, it will be mole per liter upon second into 1/, mole per liter, here it will be second, right, square. So for this square will cancel it out with this value. Now how much it is coming? Liter, because this is per liter, it will go up, so it will be liter. Then mole means per mole, because it will go up per mole, and then per second. So if you are finding this kind of unit, then it will be your second order kinetics, correct? Likewise for nth order, how we are taking place? N equal to n, right? So it will be mole per liter upon second into 1/, mole per liter. Here it will be n. So how much it is coming? It will be coming like mole per liter and then 1 minus n and then per second. See, whatever you want, you can put it, whether third order, okay, fourth order, fifth order, you'll get the value. Suppose for third order, I'm just calculating for third order. We'll do it here. N equal to 3. With this formula I am putting, so mole per liter, here 1 minus 3 per second, right? Because 1 minus n, so how much it is coming? It will be mole. See, 1 minus 3 is minus 2, right? So here it will be coming minus 2, and liter it is minus, and here minus 2. So minus and minus 2, it will be plus 2. So liter to and per second. See, likewise, if n equal to 4 you are putting, how much it is coming? Mole 1 minus 4. 1 minus 4 means how much it is coming? Minus 3. Liter, how much it will come? Minus 1 and minus 3. How much it will come? Plus 3. So 3 and per second. So likewise, you can calculate till nth, means infinity. You can calculate 1000 or 2000, 5000, whatever order they will ask. You can easily now frame it the unit, correct? So this is for unit kind, like whatever unit they will ask, everything will be finished with this slide. If you want to take screenshot, you can very much do it. I will be out of frame. Okay, done. So next we will see the order of reactions. Okay, how the order of reactions will work, that we are going to see it, because that is also required. Sometimes they'll give you the rate constant, they will give you time, and they'll ask that how much. Tell me what will be the order of reaction, or maybe they'll ask you what is the half-life. Okay, maybe they'll ask you to find rate constant. Okay, so the next will be for n. We are just finding out the rate equation. Okay, rate equation. We are just finding out the rate equation for different orders of reaction. So n equal to 0 means for 0th order we are just finding out first. It will be rate constant K equal to how much it will come? So how much it will come? R0 minus RA at T divided by T. Correct? It will be your mole per liter and then per second, the unit, because we already calculated the unit for this rate constant, right? So we will draw some graphs based on this. Okay, that graphs they will ask you directly, and they will say that okay, for first law, for 0th law, which graph is matching for 0th law, right? Suppose this is one graph. We'll see how it will work. This will be the concentration. We will write it down here, minus R T. Okay, and here we will take the time coordinate, so it will be direct. Okay, and this slope is whatever slope we are getting, it will be K. And then one more thing is that one more graph will be there, this one. If you are taking rate in y-axis and concentration, okay, concentration this one in like in this x-axis, what will happen? It will be like this. Okay, because rate is not changing, correct? Whatever the concentration is there, that concentration is fixed, correct? It is not getting changed. See, whatever the concentration you are getting, that is divided by time. So rate upon concentration, if you are having graph, it will be constant, because rate is not going to change it. It is the same rate, it will complete your entire reaction, correct? In the same rate, it will continue your entire reaction. So these two graphs will discuss your 0th order reaction. One more graph is there. We'll just see it. One more graph is there. This is like R T. How much is left out in T second versus your time. Okay, how much is left out versus your time. So how the graph will be there? It will be minus plotting, right? Like it will be negative. So what is the slope we are getting here? Minus k. So we know that for this graph how we are getting kt equal to r0 minus rt, or just write it down, rt equal to r0 minus kt. Okay, so this will be slope, right? R0 and t. Okay, for this rt, this is y-axis, and this time. Okay, and this r0 will be your intercept. Okay, initially this place we can say it is r0. Okay, because it is starting from the concentration will be maximum at time equal to 0, right? As the time is going, okay, as time is passing, the concentration is decreasing. So this slope you will get it. So total 3 graph you will get it for 0th order reaction. Likewise for first order reaction we will see it. Okay, let's see. So we are discussing rate equations, correct? So 0th order already done. So we will see the first order, how much it is coming. Okay, for first order, n equal to 1. So what will be the rate constant for n equal to 1? It will be 2.303 divided by t, time. Okay, and then log. Okay, and then log, and then here it will be r0. Okay, divided by rt. So for this equation, what is r0? It is the initial concentration. Okay, this concentration is left out after t. Okay, at time equal to time. Okay, so the left out, whatever the left out is there, that we are going to write it. So this because derivation it is not possible here. If we are starting like all the derivation, if we will start here, it will take again 25 lectures, right? So based on your upcoming examination, I am doing. So n equal to 1 we are discussing. Let's see how the graph will work for n equal to 1. Okay, with the rate. Okay, and here we will take it rt. So it will be straight line. Okay, so as the rate increases, our whatever this the concentration of product will increase. Okay, as the rate, if we are increasing the rate of the reaction, our concentration of product will also get increased, and this one is k, right? Slope is k. Okay, slope is k. So one more graph will be there for first order reaction. The different type of graphs we are discussing because it is required, because in examination when it will come, if you already discussed all this graph, it will be easy for you, right, to identify. This will be log rt in y-axis, and x-axis it will be time. So how the graph will be like this. What is the slope you are getting here? Slope will be minus k by 2.303. Correct? So which equation it is belonging? It will be like r t equal to r0 exponential minus kt. Okay, so here from this equation what you come to learn, that rate constant is directly proportional to your the concentration, right? Concentration means the product concentration. As the rate constant is increasing, the rate constant is increasing, your product formation will be also fast. It will be more and more, correct? So this is for n equal to 1. Okay, so n equal to 2 also we will see it. After that we will go for half-life. All the half-life we will discuss it together, correct? So just we will discuss it for n equal to 2. Okay, so rate equation we are discussing. So n equal to 2. What will be the k equal to? Okay, there are two chances. One is like we have this equation. So I'll write it out for this, the equation a plus b if it is giving product. Okay, so now condition 1, case 1. What is the case 1? If a equal to b. Okay, if a equal to b, then how it will be? A plus b product means at time equal to 0, it will be concentration A. This also concentration A. This will be 0. Okay, at time equal to 0 second, right? At time equal to t, what will happen? Here, some of the concentration will go away, like A minus X. Just think that X value, X product it has formed here. Likewise for B also it will be A minus X. When A equal to B, right? Both the reactant are same, right? So with this equation we are going to write it out the rate equation. Okay, so K. So now K equal to what will happen? So case 1, we are just discussing case 1 where A equal to B, right? Both the reactant is same. So K equal to will be 1 by T X by A minus X. Okay. Now case 2, here only we will write it. Case 2, when A is not equal to B, correct? So what will happen? A plus B lead to product. Now at time equal to 0, it will be A, and there this concentration is B, okay, and product concentration is 0. Now at time equal to time, what will happen? This will be A minus X, this will be B minus X, and the product formation is X. So now your equation is getting complicated. So the rate law, what is the concentration? Like rate constant equation. So rate constant equation, we'll write it. It will be 2.303 divided by A minus B, then T, then log B A minus X divided by A B minus X. Okay. So this equation, I think 2-3 times if you will, if you practice problem based on this equation, it is very much easy. So see this one for when A equal to B in case 1, what is happening? 1 upon time and then X, whatever the concentration of product it is forming, divided by A is a common, because both place it will be A minus X, A minus X. So A and then A minus X, correct? Now for when the A is not equal to B, you just put 2.303 divided by A minus B and T. So it should be 2.303 and T, right? So extra it has came A minus B, because both the concentration we have to put it. Now log, first take for B, okay, B, and if you are taking B then A minus X, if you are taking A then B minus X, okay. So it is quite easy only. So now the rate constant we have discussed, okay. Now the next point is the time, okay, half time, like whatever the T half, that we are going to discuss it, okay. So T half we are going to discuss it. Let's see how it will work, and then we will solve the PYQs, okay. Believe me, your IIT-JAM, whatever I am discussing now, it is enough for your IIT-JAM exam. You won't be asked beyond this topic, whatever topic I am discussing here, okay. After examination you will remember me, okay. So half-life of the reaction, okay. So half-life, in that first we will see for n equal to 0, 0th order we will see for half-life how much it is coming for 0th order. 1 by 2, it will be whatever concentration we have divided by 2. You can reframe this formula always. So based on rate constant, how you are going to write? A by T half, okay, 2 into T half, 2 into T half. Sometimes they will give you the T half value, okay, and they will ask the what will be the rate constant for this particular reaction. They'll give you this also, mole per liter, and they'll give you the T half value, okay, and they'll ask you the what is the rate constant of this equation. So this formula you have to put it. So just rearrange the formula and practice it, okay. So by rearranging you will get to know many things, okay. So when you are practicing you'll get to know many things. So we'll see the graph how it is working, correct. Here it will be T half, and here will be the concentration of initial concentration. This is initial concentration, okay. Initial concentration of the reactant, okay. So how it will be? It will be like this, correct. The more concentration of the more concentration you are increasing, okay, the concentration of the reactant you are increasing, T half will also get increased, correct. Based on the concentration of reactant, your T half will also get increased. So this graph belongs to your n = 0. So When n equal to 1, what will be the t half? Here t half will be 0.693 divided by k. So here one thing, it is not depending on your initial concentration. It is not this t half for first order reaction. It is not depending on your initial concentration. If you are taking A here and t half, this will be like this. Okay, you increase your initial concentration, but then also your t half will not change, not fluctuate. It is constant, right? It is constant because t half is this. This is also a constant value. Rate constant is also a constant value. If you are changing the rate constant, the constant itself, if you are changing, then only t half will get changed. Correct? Otherwise, your rate constant, if rate constant is fixed, your t half will be straight line. Okay. So these are the first order reactions graph. We'll see for second order reaction. Okay, I'll grab it here. T half for second order reaction. So we will get it to, right, T half when this is n equal to 2, right? So second order reaction, when A equal to B, then what will be the T half? And when A is not equal to B, what will be the T half? So here is the T half barabar 1 bate Ka, correct? And here if you see, when A is not equal to B, what will be the T half? 1 bate K, and then we'll write the concentration, correct? Because whatever the concentration of A and B, both will come here, okay? So you just see how this graph is looking. Both the graph will be looking like this. If you are taking T half and then concentration, based on concentration, it will be looking like this, right? Because the concentration is in like if concentration is getting increased, T half will be less, correct? Here also concentration is getting increased, means T half will be less. So as concentration of starting material you are increasing, reactant you are increasing, what is happening? The T half is getting decreased. As the concentration is low, your T half is more, right? Half life is more. So this kind of questions they have asked very frequently. They are asking this type of questions. That's why I have taken this graph and I am discussing with you, right? So now if we'll see for n equal to 3, right, the third order reaction, then only it will be clear. After third order they will not ask you for fourth order and fifth order. So T half for n equal to 3. So third order reaction, what will happen? 1 bate 2, T half equal to 1 bate K, and then whatever A you are writing, it will be square. Correct? For the concentration, square will come. So this is the T half for third order reaction. Okay. So these values you just keep it in your mind. So how and what is happening here? So for 0th order, it is directly proportional. Okay. If n equal to 0, it is directly proportional. Okay. T half is directly proportional to concentration. If n equal to 1, T half doesn't depend, it is constant, right? It doesn't depend on initial concentration of reactant. If n equal to 2, your T half is inversely proportional to concentration, initial concentration. If n equal to 3, your T half is inversely proportional to concentration, but in exponential factor, is square, right? It will be like far decrease of your concentration. If T half is more, your concentration will be very much down. Or if your concentration is initial concentration is very much high, your T half will be very less, correct? So these things you just write it down somewhere. Just see before examination, just once you see and go there, your problem will be getting solved, right? So this is the T half we have discussed for different order of reactions. Okay. So apart from this, we have many like 2 or 3 topics is left. Okay. After that, we will start discussing the problem. So those 2 or 3 topics, if I start, I have to finish it up. And as I told you, beyond 30 minutes, it is very difficult for me. So like the consecutive reaction. Okay, consecutive reactions means suppose A is giving product B and B is giving product P. Okay, so this will be K1, this will be K2. how the equilibrium you are maintaining, what will be the concentration of B, how you are finding, everything we are going to discuss it in next class. Then what all topics is there for next class? We have the simple reactions. Okay, simple reactions where we are putting steady state approximation for calculation of the rate constant. Like suppose we have reaction type A to B and then we are getting the product P, right? So in this A to B, again one more reaction, it will be like K1, so this will be K minus 1, here it will be K2, correct? So how you are finding this concentration or how you are finding the product concentration, that also we will see. We have different type of graphs. Suppose this is the graphs we have. Okay, these are the graphs we have. So this they will write it. So this will be like this is B, this is A, and this is product P. So which rate constant is more, like K1 is more or K2 is more, everything we'll discuss it in next class, and then we will discuss your previous year questions. After this class, I'm just I'm very much sure that you are not going to lose any marks from chemical kinetics. Okay, so wait for my next class, and thank you very much for watching. Have a great day.